Hey guys, today we're talking about comparing and ordering rational numbers. A rational number is a number that can be expressed as a ratio of two integers written as a fraction. Okay, so common fractions are terminating and repeating decimals, percents, and integers are all rational numbers. So I don't want you to write down all of this, but I do want you to take a look at these. The whole numbers are rational numbers. So who over here is a whole number? Okay, if you look, 1 is a whole number. All right, who out of those are integers? So integers also encompass the whole numbers, but integers are these negative and positive whole numbers. Rational numbers are anything that can be written as a fraction or a percent. So these that I'm circling are going to be our rational numbers. Okay, so rational numbers, I want you to write down, can be written as a fraction. All right, let's take a look at some more examples. A common denominator is a common multiple of the denominators of two or more fractions. Okay, so common denominators of like 1/2 and 1/4. If we looked here, we would change 1/2 to 2/4, and now they have common denominators. The least common denominator is the lowest common denominator. I could have changed both of these, one of them to 4/8 and the other to 2/8, but that's not the least common denominator. Okay, the one that's the smallest that they share when you go through the multiples is going to be your least common denominator. So for example, if I find all the multiples of 2, I could go on forever. Same with 4, I could go on forever. The least common one is the 4, but anything that they share would be considered a common denominator. Okay? So you can use common denominators to compare them. For example, 1 and 5/6 and 1 and 1/6. These already have common denominators, so they want us to compare them. So if we look at these, which one is greater first? Okay, well, think about it this. Would you rather be 1 and 5/6 in debt or 1 and 1/6 in debt? I would rather be 1 and 1/6 in debt because it's less. So if we look at the number line, here's -1, here's -2 because I'd rather be $1 in debt than $2 in debt. It's closer to 0, who's way down there. And 1 and 1/6, 2/6, 1.5, 1 and 1/4, or 1 and 4/6, 1 and 5/6, and 2. So if we graph them on the number line, they would be located here. Okay, so on this slide, you should have something about common denominators and something about the least common denominator, and then maybe at least just have this comparison. You don't necessarily need to draw the number line unless you want to. All right, so go ahead and try this one on your own. Use the number line to compare. So this time I do want you to draw yourself a number line. Okay, you can start at -5. And over here, would this be -4 or -6? Think about that. It would be -6 because this way is going closer to 0 and this way is getting more negatives. Okay, more negative as it goes. All right, so go ahead and try that one for me and then I'll be back to show you the answer. All right, make sure you paused. Here we go with the answer. Okay, so I didn't put the 5 in front of each one of these, but it would be a -5 and 1/9, a -5 and 2/9. Okay, so each one of these would be the -5 and however many ninths. Okay, so if we look at these, where would our, that 5 and 9/9, Petruska, that would be 6. And then this would be 6 and 1/9. Okay, so if we look at these here, where would -5 and 1/9 be? Right here. And where would -5 and 5/9 be? Right here. So who is the greater? Closer to 0 when we're negative makes it a bigger number. So this would be our comparison. Make sure you have that written in your notebook. Okay, so this time I don't want you to do it with a number line, but instead I want you to find common denominators. Okay, so we've got 7/12 and 8/18. First thing that I'm going to do is I want to simplify this 8/18. Okay, it would be like having 4/9. Okay, so we're looking for a common denominator with 9 and 12. Okay, so the multiples of 12 are 12, 24, 36, 48, 60, 72, 84, 96. Okay, so now let's try 9 and see if we get anywhere. 18, then we've got 27, then we've got 36, then we've got 45. Anything so far? Ooh, 36. I don't need to keep going with the multiples because I've already found a common denominator. So 7/12 equals 36 over x. This is a proportion. Equivalent fractions are proportions. So if I multiply 12 times 3 to get 36, I multiply 7 times 3 to get 21. So I have 21/36 versus, okay, now I've got 4/9, and I know that to get to 36, I've got to multiply it by 4. So 4 times 4 would be 16. And 16 over 36 compared with 21 over 36. Now remember, they're not negatives, they're positives. So I would rather have 21/36 than 16/36. All right, try these on your own. I'm going to be back in a second to show you the answers. Okay, so make sure you pause. All right, 1/5 would be like 10/50ths. Okay, so of course I would rather have that one. All right, 18 is the common denominator for both of these. So 14/18 and 15/18. So I would rather have 15. And over here, we've got 16 versus 10. You know what? If you think that it's easier to just go through and write out the common denominators, that's fine on this one. So when I go through, here's the multiples of 16. I know 80 is going to be shared because 10 clearly is divisible by 80. So if I multiply 8 times 7, I get 56, but these are negative, okay? So 9 over 16, if I simplify that to 80, I'm multiplying by 5. If you see that, 1, 2, 3, 4, 5. 9 times 5 is going to give me 45. So would you rather be a negative 45/80ths or a negative 56/80ths? I would rather be a negative 45. Okay? All right. In Mr. Millis's class, 20% of the students own roller skates. In Miss Burkhart's class, 5 out of 29 own roller skates. In which class does a greater fraction of students own roller skates? Okay, so let's look at this again. What we're doing here is we are comparing 20% to 5/29. Okay, so we want to change 5/29 to a decimal, which means I want to divide 5 by 29. I know it goes in 0 times, which means that, what about 50? It's going to go in 1 time. So 50 minus 29 is going to give us 21. Bring down another 0. It goes in 7 times. 7 times 29 is going to give us 203. And then if we take that, 29 goes into 73 times. I can stop there. It's going to keep going on and on and on. But I know that to change a decimal to a percent, I move the decimal place 2 places. So really, this is like 17.3%. Well, which would you think has more? 20%, of course. Okay? All right, you go ahead and try this one. Make sure you pause the video because I'm going to go through the answer right now. Make sure you also are striking through anything. Remember, we talked about that in the beginning of the year. All right, make sure you strike through any unnecessary information. All right, so 25% of the students like to bowl, and 12 out of 29 is what we're comparing. Okay, so I've gotten this far. So I know that 12 out of 29, if I do long division, is going to be about 41.3%. Okay, so this class has more that like to bowl. Okay, let's look at a couple more. You can order rational numbers from least to greatest. Okay, so pi is 3.1415926. This is that repeating sign, so this would be a 4 going on forever. So I want you to try to line these up. Who would be the least? Who would be the greatest? Remember, these could have zeros trailing off forever. Okay, so if you look at these numbers, who would be your least? 3.14. Who would then come next? Pi. Who would then come next? 3 44/100, and then 3 4/10 repeating. Okay, notice that I put these less than signs in because that is a true comparison. Please don't just put commas. Make sure that you have those signs. Okay, go ahead and try this one on your own. I'll be back in just a second to go through the answer. Okay, so 1/4 is like 25/100, 1/5 is like 2/10, and 23% is like 23/100. So the least would be 0.2 or 2/10, then would be 21, then would be 23, and then would be 25. Now I'm not done. I've got to put them back in their original form and make sure that I put my comparing signs. So 1/5 is less than 21/100, which is less than 23%, which is less than 1/4. And that's all I have to you. I would like to dedicate this video to Rachel Gainey in 3rd hour. Thanks. See you later.